In this video, we are going to look into group 1 elements, also known as the alkali metals. Well, just like the name, all these metals, they all have what we so-called the basic properties. PS right here. Alkalis are actually those bases which are soluble in water. So they are not really something totally different. As you can see, one of the special thing about this sort of metal are they are soft, which they can actually be cut by key. Something that's not so often we to cut things with by using key. And actually the density is low. How to say so? Well, when something that has a low density, it's because compared to water, when you put it on water, it will float on water. And just like all the other metals, they have a great shiny surface. But here's the funny thing, when we take it out, okay, they won't look like shiny surface because they will react with the oxygen in the air to form a dull surface, which is the oxide of the alkali metal. Just like the other groups we'll look into, we care about the atomic radius, the melting point, and boiling point. Down the group, not like the group 18 element, the atomic radius, although it will still increase because the number of electrons shall increase like everybody. So just like when you have a lot of shell of clothes being put onto you, your size will get bigger. But the melting point and boiling point will somehow get lower or decrease. This is because as the atomic radius increases, the distance between the nucleus and the valence electron will start to increase as the nuclear attraction force on the valence electron will get weaker. Therefore, that's why your melting point and boiling point will start to decrease. All the elements in group 1, okay, so they will have one valence electron. So there are students actually who mistaken that hydrogen is also a member of the alkali metal. However, hydrogen is always a non-metal, which makes it being excluded from the group 1 alkali metal family. Although it's being placed in group 1, but it is not an alkali metal. That is a very tricky part. Now, let's look at the chemical properties. What does it mean by chemical properties? The word chemical properties is trying to tell you it is what kind of a chemical reaction that this substance can have. For example, which kind of reactant it can react to produce what kind of products, which is a very useful and interesting part that we are going to study in chemistry because it tells us what is going to happen after many sort of experiment and patterns they are being observed to help us to know what is going to happen. So one of the things that I mentioned in the previous video mentioned is if you have the same number of valence electrons, you are going to be put into the same group. That is actually making sense. But of course, not most of the time we will get this. So sometimes things need to be done through experiments. Right here, there is also a very important concept to be mentioned. If we are able to observe similar chemical properties, it is also one of the methods that we can say the reason why they are being put, or two elements are being put in the same group, although it's not as reliable as the one that I mentioned previously. So the first chemical property of alkali metals that we can mention is what things can react with. Now, two things to notice: what it can react with and what it's going to produce. Firstly, all the alkali metals can react with water, like sodium. When it reacts with water, it will produce sodium hydroxide and also hydrogen gas. The sodium can be replaced with all the other elements in the group 1 family. But of course, except hydrogen, okay, all the alkali metals will do the same thing. If you replace it with lithium, then lithium can react with water to produce lithium hydroxide and hydrogen gas. If somehow the group one, the alkali metal reacts with oxygen, then it will give you the oxide. Well, many kinds of many elements. Okay, not just group one. Any elements when they react with oxygen, they will give you the oxide of that element. Okay, pretty straightforward on this one. And as for the halogen, it's going to be tricky. Halogen is going to be producing salt when you have alkali metal react with it, which is why somehow something is a bit, you might observe a very familiar pattern in here. Most of the reaction, if you want to produce a salt, okay, the best way to do it is through neutralization. So here's maybe a spoiler. You can say that alkali metal, yeah, you know that is a base, but halogens, they are actually indeed acidic. Now, the next thing that is interesting to study about the chemical properties in group 1 or alkali metal is somehow the reactivity is changing down the group. So, do remember, all the chemical properties are closely related to the number of valence, not just that number, actually to the valence electron. So, anything to do with valence electrons, such as the number of valence electrons, the distance of the valence electron from the nucleus, are going to affect the reaction greatly. As you can see, going down the group, our atomic size is going to increase. What is going to happen? So, in other words, the valence electron is going to get further away from the nucleus, and the strength of the attraction force on the valence electron is going to get weaker. Hence, if somehow the strength of the nuclear attraction force gets weaker, it means that you are going to lose more easily, or you are going to, let's say, you're going to donate more easily. That is why the reactivity somehow, as a conclusion, it will increase down the group because you need less energy to actually remove the electron from the outermost shell. And then the third one is to remember that group 1 element is always going to form a cation with positive 1 charge. No matter what kind of substance is going to react, group 1 element is so reactive that it can only donate 1 electron to form the ions with positive 1 charge. It can no longer donate any more electrons, which is why that makes it the charge of positive 1 for its cation.